Okay, welcome to the second video this week. So now that I've gotten your emails and you have this new link, let's get started. One of the things I asked you to do was to group those materials and the results from both the cabbage juice test and the litmus paper test, and you've told me that in your emails. And so I think most of you have come up with something along the lines of this. So with the cabbage juice, you basically grouped things by color. So maybe it's sort of a reddish color, a blue color, and then maybe a yellow-green color. And then with the litmus paper, you group them either as materials that turned red in both the red and the blue paper, or they turned blue in both the red and the blue paper. So the question now is, what is it about those materials that makes them do that? And why can we group certain materials together? So in order to answer that question, we need to do some chemistry. You should all know that matter is made up of atoms. So examples would be a hydrogen atom, carbon atom, an oxygen atom. If you haven't done much reading or learning about atoms, I'll provide some materials and resources for you to do some work on your own. But for now, it's just important to know that all matter is made up of small particles called atoms. Now those atoms get together and they join together in what we call a bond. So they are chemically bonded together. So in the case of water, you know that water is H2O. What that means is that there are two hydrogen atoms and there's one oxygen atom in a water molecule. And so when atoms come together, they form molecules. A compound is a special molecule that has two or more elements in it. So you might hear the term molecule or compound. They aren't the same, but unfortunately we do seem to use them interchangeably. So here's some other examples of compounds that are formed when atoms come together, like hydrogen peroxide has two hydrogens and two oxygens in it. Glucose, which is simple sugar, is 6 carbons, 12 hydrogens, and 6 oxygens. And then propane is 3 carbons and 6 oxygens. So there's another phenomenon that takes place, and that is sometimes we have particles that are charged. They have an electrical charge to them. Hydrogen often will take on a positive charge, and another compound called hydroxide, OH together, takes on a negative charge. And that's important to help us understand the cabbage juice reaction and the litmus paper reaction. So for example, when all of those materials that showed red in the testing or on the red side of the cabbage juice indicator actually have a lot of hydrogen atoms in them. Because of that, they react a certain way to the cabbage juice and all to the litmus paper. We call that having a low pH. And pH is a measure of an acid or a base. So if you have a low pH number, which means you have a lot of H plus ions in that compound, then you have a low pH or an acidic or an acid material. The same thing's true at the opposite end. If you have a lot of OH minus ions, the hydroxide ions, then you have a high pH number, and we call that a base. So what we were looking at last week with the cabbage juice and the litmus paper was a measure of whether something is an acid or something is a base. Now I'm going to give you some reading that I want you to do on your own, and I'll direct you to a website to do that. Read through this material about acids and bases, and in your notebook be sure to take notes, but especially write down the acid-base scale. And notice that it starts at a 0 and it goes all the way to 14, and I just want you to put that in your notebook and then figure out what a neutral is and what that really means. So as you're going through this reading, make sure you're taking notes, and then we will talk about that in class on Thursday. Think about why I'm having you do this in terms of your biome jars. Why do we even care about the pH or the acidity or the basicness of the biome jars that we're working on? Think about that and we'll talk about it on Thursday. See you then. Thanks. Bye.